being able to count the number of faces that a geometric solid has is a very important part of our lesson today. If you flip it over and look at our aim for today, you'll see that we are looking to find the surface area of three-dimensional solids. So, first of all, we have to talk about what is surface area. What is surface area? Those of you who aren't familiar with the concept, break it down. Surface and area. What do we think surface area is? The surface of the area. Okay. Jasmine? Area of what surface? So when we're talking about three-dimensional objects, what are we talking about? What do we think? Can't use area and surface to define them. Yes? Yeah, finding the area outside the shape. So it is the surface area is the combined area of the outside of a 3D object. So when we talk about surface area, we talk a lot about surface area in a lot of different ways. One way we talk about surface area is we can talk about wrapping a gift. We can talk about painting a wall, carpeting an entire building. So these are all things where you have three-dimensional objects that you are trying to cover with something, not necessarily fill with something. We don't want to fill the entire room with paint. We want to cover the room with paint. So it's the same idea with surface area. So for instance, the example is Mr. Boots bought a gift for his girlfriend and is trying to determine if he has enough wrapping paper to wrap the gift. How much wrapping paper does he need to cover the surface area of the box? I don't have a box with me, so we're going to use this tissue box. And we are going to estimate the size of this tissue box to be 4 inches wide, so that's 4 on the front, 11 inches deep, and 3 inches tall. Now, looking at this particular box, what type of three-dimensional geometric solid is this? Black. Rectangular.
Prism.
Prism. Rectangular prism. It has how many bases? 2 bases, so it's a prism. How many faces, total faces, does this rectangular prism have? Thank you for raising your hand, Brianna. Which means how many surfaces, how many faces am I going to be having to cover with wrapping paper? 6. Which means I need to find the area of all 6 of those faces to find out if I've got enough wrapping paper or how much wrapping paper I need. So in order to do that, the way that we're going to show our work is we're going to go through and we're going to redraw each face. So we're going to start with the first face. That's the front of the box. It's got the tire guy and the weird fuel guy on it, all right? The front.
Oh, the Italian guy and that.
The front.
The hippie.
All right.
Luigi.
All right, so looking at the front of the box, if we look at our dimensions here as we've drawn them, what are the dimensions of this rectangle? Okay, it's a rectangle. What are the dimensions? What are the length and width? Don't call out. Raise your hand when you know it. Richard? 4 and 3. So we're going to go back over to where we drew that. Or where we're going to draw that. And it is 4 by 3. Now, one great thing about rectangular prisms is that the front and the back are the
same.
same. In fact, they even have the same picture on this tissue box. How nice is that? So that means if we want to draw it, what dimensions does it have? It's a rectangle that is 4 by 3. Alright, so let's check out the sides with Lightning McQueen and Mater.
The funniest dude.
So looking at our drawing of it, as we've already labeled it, what are the dimensions of the sides with Lightning McQueen and Mater here? Jeremiah?
3 and 11.
3 and 11. So when we come back over here to draw the left-hand side, you need to draw a rectangle that is 3 by 11. And what about the right-hand side? What about the right-hand side?
The same.
Good news. Look at our box. They're the same.
It is on purpose to make it go.
I know. I'm so awesome, right?
Yeah.
And finally, what are the two surfaces, the two faces that we have not dealt with? Anthony. Top and bottom. Oop.
He's gonna kill it.
Top and bottom. So let's come back over here to our picture. And the top is not particularly well labeled. As I look over here, there's nothing labeled up here for the top, but the bottom definitely is. If I look at the bottom, what are the dimensions of the rectangle on the bottom? Geronimo. 11 and 4. Right, that front is 4, going back is 11. So we should be drawing a rectangle that is 11 by 4. And the top and bottom are the same.
Same. Lo mismo.
Right. So now we got to go about finding out how much wrapping paper to cover the front. So I need area equals length times width because it's a rectangle. And 3 times 4.
8 equals 12.
8 equals 12. So I need 12 square inches of wrapping paper for the front.
That's a big box. No.
You know how big the box is. It's right here.
I know, but 11, 12 inches.
Looking at our area for the back, I need to find out how much area of wrapping paper I need to cover the back. So to cover the back, I need 12 square inches. Moving on to the left. If I want to cover the left side of this box, length times width equals 11 times 3. I need 33 square inches of wrapping paper to cover the left side of the box. Moving over to the right-hand side. Again, it's a rectangle, so it's length times width. It's 3 times 11. Area equals 33 square inches of wrapping paper to cover the right-hand side of the box. Don't want to leave that top and bottom uncovered, so I need to find out the areas for those as well.
Well, you could have made the top or the bottom uncovered.
That looks tacky. Come on now. When's the last time somebody gave you a gift with the bottom unwrapped? Come on now.
My dad did that.
How tacky is that?
I don't know.
So I find out to cover the top, I need 44 square inches of wrapping paper. And on the bottom, I also need 44 square inches of wrapping paper. Now, that being said, nobody's ever going to ask you, go through and individually find the areas of each face so we can cut out the wrapping paper for each of that. Realistically, if I'm going to go buy wrapping paper, I need to know how much total wrapping paper. So surface area means I need the total surface area, which means I need to do what here to finish up to find the total surface area. Keyword being total.
Toto.
Brianna, add it all up. So I have a 44 plus a 44. This is a really great place to check to make sure that you've got everything. I was about to make a mistake right there. 33, 12, and 12. When you're getting ready to add, you should make sure you have the correct number of numbers being added here. So I know this is a shape that has 6 faces. I better be adding 6 numbers. Count up 1, 2, 3, 4, 5, 6. Good to go. 2 plus 2 is 4. Plus 4 is 8. Plus 4 is 12. Plus 3 is 15. Plus 3 is 8. Carry the 1, 2, 3. Plus 4 is 7. Plus 4 is 11.
7-Eleven?
Plus 3 is 14. Plus 3 is 17. 178. So my total surface area is 178 square inches. So all it is it's finding out how much do I need to cover each face. Let's put it all together. That's surface area. Simple as that. We're going to do one more example over here. Hang in there, dude. Alright, it says Mr. Curry built a small pyramid to decorate the room for his ancient Egypt unit. He bought a very small can of paint that claims to cover 200 square centimeters. Find the surface area of the perimeter to determine if he has enough paint. So it's got a picture of his pyramid sitting down here at the bottom. And the first thing that we always need to ask ourselves to make sure that we're drawing the right number of faces is, how many faces are there?
5.
Okay, so this is just like the pyramid, rectangular pyramid that we saw during our do now, and it has 5 faces. So we need to redraw each of the faces. Which face would you like to redraw first?
The first, the top. No.
Sammy? Which face would you like to redraw first?
No, say the bottom.
Shh. Patience, prudence. The back. So if we come to the back, we see the back is a triangle back here. We don't know a whole lot about that triangle immediately. We know that the back should be the same as the front. So let's actually do the front and the back at the same time then. Both of them are triangles, so let's draw a triangle. And I'm going to need a height for that, and I'm going to need a base for that. So what is the base of the triangle for the front and the back? Cassandra? 14 and 12, those look like 2 different heights. So when we look at that, this 14 is measuring from the very point all the way down to the bottom here, and the 12 is measuring from the point all the way down to the bottom here. Are those the bases of that triangle? No, so what is the base of the triangle? We're dealing with the front and the back, not the left and the right. That would be looking at the right-hand triangle. We are not looking at the right-hand triangle. That would be the height of the right-hand triangle. 14 would be the height of the front triangle, which we do need to know, so let's go ahead and label that one. Oh, excellent. Process of elimination. 8. If we look right here, we're looking at this front triangle. We're looking at this front triangle right up front, and so the base, the bottom of that triangle, right here is 8. Area equals base times height divided by 2, so A equals 14 times 8 divided by 2, which is 56. Bless you.
Ow!
So, we've now taken care of the front and the back of our pyramid. Which two faces would you like to deal with next, Jeremiah? Or what face? Sorry.
The left and the right.
Okay, he wants to deal with the left and the right. So if we're looking at the left and the right, we're looking over here. So face 3 is going to be our left, and our face 4 will be our right. What are the dimensions of our triangle on the left? Anthony. The base is 6, the height is 12. Same thing on the right hand side. So if we want to find the area, that's area equals base times height divided by 2 equals 12 times 6 divided by 2, and that would give me 36. I do it fast because I've already done it twice today.
Do it very, very fast.
I also do it fast because I can think about it as this is a 6 times 2. Cancel out 2 and 2. 6 times 6 is 36.
That's the way that I do it.
That's how we do.
Plagiarism.
This is how we do.
That's how we do it.
This is how we do.
You recorded yourself, Mr. Boots?
Yeah, I know.
No, he recorded my sneeze.
That's unfortunate.
He recorded.
Okay, now we've got one face left according to our calculations. We said there were 5 faces. What face do we have left to find the area of? Adriel, the bottom. So this is our bottom down here. And what is the shape of that bottom?
The square? Square.
It's not a square.
Rectangle. Rectangle. You don't know what the
It's a rectangle. So we know this is a rectangle, and what are the dimensions of this rectangle? Monique. 8 and 6. So the area of a rectangle is length times width. So 8 times 6 and is 48. But we've still got one thing left to do if we want to find the total surface area.
Add everything. No.
Let's add it all up. Let's see, 56, 56, 36, 36, 48. 6 plus 6 is 12, plus 6 is 18, plus 6 is 24, plus 8 is 32. Carry the 3. 3 plus 5 is 8, plus 5 is 13, plus 3 is 18, plus 3 is 21, plus 4 is
232 centimeters.
25. Hold on, let me check my math on that one. 8, 13. Yeah, you're right. It was 23.
Yay!
Somebody over there tried to trick me.
Me.
232
Sticker.
centimeters squared.
Listen to me, son.
Okay.
Yeah.